In this episode, we'll talk naming alkanes, see a common professor trick, go to the whiteboard to draw some structures, and find a website that has a new molecule for you to learn every single day.
Welcome to the AceOrganicChem.com podcast. With videos, flashcards, ebooks, a test bank, lab help, and a best of the web. AceOrganicChem.com is your ultimate stop on the web for organic chemistry help. And now your host, Dr. Mike.
Well, thank you very much and welcome back. First and foremost, before we go any further, I would like to say thank you. We had a really great response to our first podcast. It was really nice. We appreciate the good feedback, and we appreciate you guys coming back for number 2. I'm going to apologize ahead of time. I am a little bit under the weather today, so I don't generally sound like Barry White, but I think we can get through it today. And today we're going to be talking about alkane nomenclature. Now, you've probably already seen this for about a month or so in your organic chemistry class, but that doesn't mean it's not important, and it's really something we want to lock down. So I thought it was worth dedicating a podcast to. So without further ado, let's get started. So nomenclature. We follow the IUPAC rules for nomenclature, and basically that says identify your longest carbon chain in your molecule. That's step 1. Step 2, identify the substituents that are coming off of that carbon chain. I like to circle them. It makes things nice and simple. Then 3, number your substituents from highest priority to lowest priority. Let's see an example of this and we'll get started quickly. Right, so we have that molecule. I apologize if it's a little light. I make a little box around the carbon chain just like I did there. So this carbon chain is 1, 2, 3, 4, 5, 6, 7 long. Is that 8? 1, 2, 3, 4, 5, 6, 7. It is 8. All right, good. Never hurts to count twice. Now, step 2, identify those substituents. There's 1 and there is 2. So we have an ethyl and a methyl group on there. Then number them from highest priority to lowest priority. Now, what we want to do is ensure that we have the lowest combination of numbers. So, for example, this would be 4-ethyl, 3-methyl octane. We need to start with that 3 because in this case we want to number from right to left, not left to right. So if we had gone from left to right, we would have ended up with, what, 2, 4, 5. It would be like 5-ethyl, 6-methyl, right? We want 4-ethyl, 3-methyl octane. Here's the caution. Here is a trick.
It's under control, sir.
They will pull this on you. The longest chain is not necessarily in a straight line. What do I mean by that? Here is an example. And again, I apologize if that's a little light. There is our longest carbon chain. It is not in a straight line across. So what I've circled is actually a substituent. This is not a heptane, it is a nonane. Our longest carbon chain is 9, not 7. Be very careful of that. Professors are not creative. Organic chemistry for them has not changed in 30 years. Don't fall into these traps. This is a nonane, not a heptane. And there's the actual name, 3-methyl-4-propyl nonane. So let's go through a practice problem here. Give a formal name for this compound. And I threw a little stunt at you here. We have a bromine somewhere in there. So take 2 seconds, pause the podcast if you have to. Do this problem and we'll move on in a second. All right, so there is the name. 2-bromo, 5-ethyl, 3-methyl nonane. Again, put a box around the longest chain and circle your substituents, and that's the easiest way to do these problems. There's the box, there's your circles. Alright, so let's get our whiteboard demo started. Now, I'm going to draw a simple structure. 2, 3, 4, 5, 6 carbons. There it is. 6 carbons is a hexane. Very simply, add a substituent on. 1. Now it's a 2-methyl hexane, right? 2-methyl hexane. What if I kept going with this? Uh-oh. Not a hexane anymore, is it? This is the trick that professors love to use. I'm telling you, they are not creative. They can't come up with new stuff. They're going to use the same stuff over and over again. This is one. This is no longer a hexane. 1, 2. Here, let me get. Ready? 1, 2, 3, 4, 5, 6, 7, 8. It's a nonane now. I'm going to guess 1, 2, 3, 4, 5. Yeah, 5-methyl nonane is what this has become. Also like to show you some substituents, some names of substituents that you're gonna run into here. All right, so let's delete this. Let's go back to our hexane. All right, we have 1-methylhexane now. We're going to add 1 to each. Right now it is a heptane because we've added a carbon to the branch. We have 1-ethyl heptane. When we turn the substituent into a Y, right, this substituent, I'm going to put a box around it, that substituent is an isopropyl substituent. Isopropyl. You're going to see that a lot. So you might see this called 1, 2, 3, 4, 5, 6, 7. This would be 3-isopropyl heptane. Doesn't need to stay that way, though. We can keep adding things. Let's get rid of that, get rid of that. If it were like this, this is now a tert-butyl group. And again, I'm sure you've seen these before. So this would be, it can be called a T-butyl group, or a tert-butyl group is the more formal name to it. 3-tert-butyl heptane. Now, this is a group that you might not have seen before. I'm going to start over. Just erase this whole thing. Now, ready? Draw a structure out, and then I'm going to now let's connect this group to something because I want to demonstrate what this is. Okay, so this funkiness here. This group right here is much worse than a T-butyl group. This is a neopentyl group, right? Pentyl because it's got 5 carbons there. Neopentyl groups primary, right? You think that's a primary carbon coming off there. It's not. It's much worse. It's way bulkier because it's way shiftier and bigger, and it can flop around. So that is a neopentyl group. If you see that, that's what it's talking about. So a little bit of nomenclature for side chains now. And again, do not forget the very basics. 4, right? So meth, eth, prop is 3, but is 4. If we go to 5, we're at pent. If we go to 6, we're at hex. So you can have hexyl groups coming off of there. 7 would be a heptyl group. And, alright, so there's cyclohexane. There is 1-methyl cyclohexane. Right, you can even have cyclohexyl substituents coming off of things. So 1, 2, 3, 4, 5, 6, 7, 8. This is 1-cyclohexyl octane. Right, the cyclohexyl is your substituent because the longest chain's up here. So anyway, that's our whiteboard for today. And finally, our site of the week it comes from Science Blogs, which as the name would make you think, is a website that has lots of blogs of people who blog in the science area. It can be in chemistry, biology, astrophysics. It goes all over the place. But the one that caught my eye was Molecule of the Day. Now, I'm going to warn you ahead of time. It appears that the site has stopped publishing. It stopped publishing in 2010, so you're not getting a new one every day. However, going back through the archives is really nice, and I think it gives a nice mix of advanced molecules with undergraduate sophomore molecules that you guys can understand and really gain an appreciation of what these molecules do, how they're constructed, and really their overall chemistry, because you shouldn't be bound to just these simple organic molecules that you'll see in your undergraduate class. Expand a little bit. You will see common themes in more advanced molecules that you see in the simple molecules all the time. And you might not understand the whole thing. It doesn't mean that it's not still worth it. So I would suggest that. Once again, thank you very much for watching, and good luck with your class. We'll see you back here next week.
That's it, man. It's game over, man. It's game over.